What if the whole idea of genius is backwards? What if the people who seem impossibly brilliant aren't blessed with some magical gift, but rather they've simply learned to use their mind in a way that anyone can learn? Most people think intelligence is fixed. You either have it or you don't. But watch what happens when someone truly understands something versus when they've merely memorized it. The difference isn't in the brain they were born with, it's in how they've trained that brain to work. The real question isn't whether you're smart enough. The question is, are you thinking or are you just collecting answers? Here's the problem. Walk into any classroom, any library, anywhere people are trying to learn, and you'll see the same mistake repeated endlessly. Someone sits down with a textbook. They read a page. They underline the important parts. They read it again. Maybe they copy some notes. They feel productive. They feel like they're learning. But ask them to explain what they just read without looking at the book and watch what happens. They stumble. They use the exact phrases from the text. They can't put it in their own words. They certainly can't explain why it's true or what it really means. This is the illusion of knowledge. It feels like learning because you're doing something. Your eyes are moving across words. Your hand is moving across paper. But your mind is just a passive receiver, letting information wash over it like water over a stone. The brain doesn't work by absorption. It works by reconstruction. This is fundamental, and most people never grasp it. Think about what happens when you really understand something. Let's say you're trying to understand why heavier objects don't actually fall faster than lighter ones, despite what seems obvious from everyday experience. You can memorize that Galileo proved this. You can write it down. You can repeat it on a test. But do you understand it? Understanding means you can rebuild the idea from scratch. You can explain why a feather and a hammer fall at the same rate in a vacuum. You can work through the reasoning. You can answer questions you've never been asked before because you grasp the underlying principle, not just the conclusion. This is the first key to training your mind. You must become an active rebuilder, not a passive receiver. Here's how this works in practice. When you encounter an idea, any idea, your immediate instinct should be to take it apart and put it back together in your own way. Don't just read that energy equals mass times the speed of light squared. Stop. Ask yourself, what does that actually mean? What's energy? What's mass? Why would they relate this way? What would happen if this weren't true? Take a simple example everyone learns. The area of a circle is p times the radius squared. Most people memorize this formula. They use it on tests. But do they understand it? A trained mind approaches this differently. Why should the area depend on the radius squared? Well, if you double a radius, you don't just double the area. You create a circle that's twice as wide and twice as tall. So the area should increase by a factor of 4. That's the squared relationship right there. And pi, that's just the proportionality constant that comes from the specific geometry of circles. See the difference? One approach gives you a formula to plug numbers into. The other gives you understanding you can use to figure out related problems, to spot mistakes, to actually think with the knowledge. This leads to the second principle. Test yourself brutally. The mind is a master of deception. It convinces you that familiarity equals understanding. You've seen an equation before, so you feel like you know it. You've heard an explanation, so you believe you understand it. But familiarity is not understanding. The only way to know if you really understand something is to close the book, put away the notes, and try to explain it from scratch. Better yet, try to explain it to someone else who knows nothing about it. Or write it out as if you're teaching it. This is uncomfortable. This is where you discover all the gaps in your understanding. That equation you thought you knew, suddenly you can't remember why that term is negative. That process you thought you understood, you realize you skipped 3 steps in your mind without noticing. Most people avoid this discomfort. They keep rereading. They keep reviewing. They stay in the safe zone where they can look at the material and think, yes, yes, I know this. But recognition is not recall. Recognition is not understanding. A trained mind seeks out this discomfort. It deliberately tests itself at every step. After reading a section, close the book. What were the main ideas? Can you explain them without looking? Can you solve a problem using those ideas? If not, you haven't learned it yet. You've only been exposed to it. The third principle might seem contradictory. Play with ideas. Learning isn't meant to be grim determination and forced memorization. The brain learns best when it's curious, when it's exploring, when it's asking what-if questions. Take any concept you're trying to understand and push it to extremes. What happens if this number gets very large, very small, zero, negative? What if you reverse the process? What if you change one variable? Suppose you're learning about levers. Don't just memorize the formula for mechanical advantage. Play with it. What happens if you make the fulcrum very close to the load? The force you need gets smaller, but you have to move your end much farther. There's a trade-off. Why push it further? What if the fulcrum is right at the load, at your hand? The formula breaks down in interesting ways. This kind of play isn't wasting time. This is how understanding deepens. You're exploring the boundaries of an idea, seeing where it works and where it fails, building intuition that no amount of memorization can provide. Here's something profound about how the mind actually works. It doesn't store information in neat labeled boxes. It stores connections, patterns, relationships. When you play with an idea, when you connect it to other things, you know, when you look at it from different angles, you're building a web of associations, and that web is what makes knowledge retrievable and useful. Think about someone who's genuinely skilled in mathematics. They don't just know formulas, they see relationships, they recognize patterns. They can approach a new problem and think, this reminds me of that other thing. Maybe I can use a similar approach. That ability doesn't come from memorization. It comes from playing with ideas until the connections become natural. The fourth principle, simplify ruthlessly. There's a test for whether you understand something. Can you explain it simply? Not with jargon, not with complex terminology, but in plain words that anyone could grasp. Complexity is often a mask for confusion. When someone explains something using lots of technical terms and elaborate constructions, it's frequently because they don't really understand it themselves. They're hiding behind the language. Real understanding strips away the unnecessary complexity. It gets to the core of what's actually happening. Take the concept of entropy. In textbooks, it's described with statistical mechanics and thermodynamic equations. But what is it really? It's the universe's tendency toward disorder. A drop of ink spreads through water because there are vastly more ways for the molecules to be spread out than concentrated. That's it. That's the fundamental idea. The mathematics describes it precisely, yes, but the core concept is simple. When you're learning something, keep asking, what's the simple version? What's really going on here beneath all the fancy language? If you can't find the simple explanation, you probably don't understand it yet. This doesn't mean everything can be reduced to a sentence. Some ideas are genuinely complex. But every complex idea is built from simpler components. Break it down, find those components, understand each piece, then rebuild. Now, here's what's really happening. When you train your mind this way, you're not just learning specific facts or techniques. You're changing how your brain processes information. The brain is remarkably plastic. It physically changes based on how you use it. When you practice active reconstruction instead of passive reading, you're building stronger neural pathways. When you test yourself, you're strengthening recall mechanisms. When you play with ideas, you're creating connections. When you simplify, you're organizing information in more efficient patterns. But there's something deeper still. You're developing what might be called intellectual independence. Most people are taught to trust authorities, to accept what the textbook says, to memorize what the teacher explains. But understanding requires skepticism, not stubborn denial of facts, but healthy questioning. Why should this be true? How do we know this? What evidence supports it? What would prove it wrong? This skeptical mindset is crucial. It forces you to actually think about what you're learning instead of just accepting it. And remarkably, this skepticism often leads to deeper understanding than blind acceptance ever could. Consider any scientific principle you've learned. Don't just accept it because it's in a book. Think about the evidence. What observations led to this conclusion? What experiments tested it? Are there alternative explanations? Understanding the path to knowledge is often more valuable than the knowledge itself. This isn't about rejecting established science. It's about understanding why it's established, what makes it reliable, where the boundaries of our knowledge lie. Let's bring this down to practical application. Suppose you're studying physics, trying to understand Newton's laws of motion. Here's what the untrained approach looks like. Read the laws, memorize them, practice plugging numbers into formulas, pass the test, forget everything in 6 months. Here's what the trained approach looks like. Start with the first law. An object in motion stays in motion unless acted upon by a force. Don't just read it. Close your eyes and picture it. A puck sliding on ice keeps going until friction stops it. But what if there were no friction? It would keep going forever. Why? Because there's nothing to stop it. That's not obvious from everyday experience where everything slows down. But in space, objects do keep moving. The law suddenly makes sense. Now test yourself without looking. Can you state the law? Can you explain why it seems wrong in daily life but is actually true? Can you give examples? Now play with it. What about circular motion? An object moving in a circle is constantly changing direction. Does that violate the first law? No, because changing direction requires a force. The string pulling the object inward, or gravity pulling a planet toward the sun, the law still holds. Now simplify it. What's the core idea? Things keep doing what they're doing unless something makes them change. That's inertia. That's the fundamental insight. Do this with every concept. Make it your own. Don't be satisfied with memorization. Demand understanding. Or suppose you're reading history. The fall of the Roman Empire. The untrained mind reads about dates, emperors, battles, memorizes key facts, forgets them quickly. The trained mind asks different questions. What were the underlying causes? Economic, political, military. How did they interact? Could the fall have been prevented? What patterns appear here that show up in other civilizations? How do we actually know what happened so long ago? What evidence exists? What speculation? This deeper questioning transforms history from a list of facts to memorize into a fascinating puzzle to understand. And paradoxically, this approach makes the facts easier to remember because they're connected to understanding rather than floating in isolation. The same principles apply to learning a language, understanding music, studying mathematics, mastering a craft, active reconstruction, brutal self-testing, playful exploration, ruthless simplification. These aren't specific to one field. They're how the mind learns anything deeply. But here's the beautiful part. As you practice these techniques, something remarkable happens. Learning becomes easier, not because the material gets simpler, but because your mind becomes stronger. You develop mental tools that work across domains. You build confidence in your ability to figure things out. You stop being afraid of difficult material because you know how to break it down and understand it. This is what people mistake for genius. It's not some innate gift. It's a trained skill. The difference between someone who seems brilliant and someone who struggles isn't the brain they were born with. It's how they've learned to use that brain. Think about the implications of this. If understanding is a skill you can develop, then the limits on what you can learn are far broader than most people imagine. That subject that seems impossibly difficult, it's probably just being approached wrong. Those people who seem naturally talented, they've probably just developed better learning strategies, often without even realizing it. The tragedy is that most educational systems teach the exact opposite of what actually works. They reward memorization. They discourage questioning. They present knowledge as finished facts to be absorbed, rather than ideas to be rebuilt and understood. They create the illusion that learning means hearing information, when real learning means transforming information into understanding. You can break free from this. You can train your mind. Start small. Pick one thing you're trying to learn right now. Apply these principles. Close the book and try to explain it. Test yourself ruthlessly.
Play with the ideas. Simplify them to their core. It will be uncomfortable at first. You'll discover how much you don't actually understand. That's good. That discomfort is the feeling of real learning happening. That's your brain being challenged to actually think rather than just absorb. Stay with it. Build a habit. Make this how you approach everything you learn. And watch what happens over time. Understanding compounds. Connections multiply. The mind strengthens. There's a profound satisfaction in genuine understanding that memorization can never provide. It's the difference between carrying someone else's conclusion and discovering the truth yourself. It's the difference between knowing that something is true and understanding why it must be true. This is available to anyone. It's not reserved for the gifted few. It's simply a matter of training your mind to work the way it was meant to work. Actively building understanding rather than passively collecting information. The universe is knowable. Reality follows patterns we can comprehend. The laws of nature, the structure of mathematics, the flow of history, the logic of language, all of it can be understood by a mind willing to do the work of understanding. So here's the challenge. Stop asking whether you're smart enough. Start asking whether you're thinking deeply enough. The genius you admire in others, it's not magic, it's method, and that method can be learned. Your mind is more powerful than you've been taught to believe. Train it properly, and there's almost no limit to what you can.